There's like a ding, ding, ding before I record. Anyways, sorry. Okay, we are going to talk about our other type of compound inequalities today. So last time we did our solving and compound inequalities, which is just two inequalities connected with the word and. So today on 35 and 36, we're going to talk about solving or compound inequalities. I think the word but is also a compound word, but I don't think we have but inequalities in math, sadly. Okay, so let's turn to 35. So on 35, we have our or. And over here, I have some examples that I'm going to try with you like we did on the last one. So let's first look at our scenarios here. With or with and rather, remember, and was always about the overlap. If I take one graph and put it on top of the other, where do they overlap each other? And that's what I take. Or is like this one or that one. So it kind of can be both at the same time. So looking at our first scenario here, we're saying that it's cool. X can be less than 4. So like this. Or it's cool. X can be greater than or equal to to 6. So equal to filled in circle, and we'll go this way. So basically I can take both those graphs because I can be less than 4, or it's cool and you can be greater than 6. So overall, my graph is going to be both of those things. Like the or compound statement is both of those graphs at the same time. So our set builder notation for this one, you guys, again, little fun curly cues around it, doesn't really change. X is less than 4, or X is greater than or equal to 6. It's the same. Kind of easy, I think. Another scenario that we can have, it's like this one here. X is greater than or equal to 4. So equal to means it can be filled in. And it's greater than that. Or X is greater than 6. And so again, it's kind of like our and, where like they're going in the same direction. But I can be both, like it's cool. So like if I take this graph and put it on that one, I can have all of the things all at once. And so really, because X can be bigger than 4 or bigger than 6, it's cool if you're just bigger than 4. So with this one, you actually get to have more things. Unlike the and, where I had like less things. So I had to cut off the extra here. Here I get to take the extra. So really, this one is really just X is now greater than or equal to 4. Because the 6 is already included in that. Like I really don't need to say it again. So X is greater than or equal to 4. Or the last or scenario, too many ors, is X is greater than 4. So this way. Or it's cool. X can be less than 6, less than or equal to 6, excuse me. So equal to filled in dot, and that way. So it's like, it's cool. You can be bigger than 4, and you can be less than 6. And so if I take both of those things at the same time, I think I'm the entire graph. Like if I take this one and put it down here, it's like all the things. My whole graph is full. And so what happens in this case, when I can be bigger than 4 and less than 6, I think I can be all the numbers. So all real numbers. That last scenario in both of these are kind of those weird answers that we talked about before when we were solving and like X's disappeared. This is kind of like that overlapping stuff where either I get all the numbers, so all my number line, or like in this one, none of them. Okay, now again, just like we did the last time, I'm going to leave the inside ones for us to do together. And then over here, we want to leave some space at the top because I want to do that in my review video for later this week. But let's do a couple of solving examples down here. Okay, so if you need to take a pause and write those down. Really, when we're solving an or compound inequality, it's not really too different than solving like two inequalities. I just have to like think about the graph a little bit more carefully. So I always tell this funny story. Many years ago when I taught freshmen originally, you guys are much smarter than them. I had a couple of students who would do that, like they thought this was a choice, like they can solve this problem or that one. They didn't have to solve both, which is not the case. You do have to solve both. The or just means that like it's cool if you're both. So you still have to solve both. So I'm going to put in my sides. I want to solve for x, so we would get rid of addition or subtraction first. So I'd subtract 2. We'd have 3x is less than -9. And then I divide 3 away. And because the number I'm putting on both sides is not negative, I will not change my sign. So 3 divided by 3 is 1x. I bring my sign down. And when I divide there, you're -3. Or, so like x has to be less than -3. Or, we're going to solve over here. I would not mess up. I wish. I mess up all the time. I'm so sorry. We're going to subtract the 5 on both sides. Get rid of addition, subtraction first. And then we'll have -4x. I'll bring down my inequality. And then 1 minus 5 is -4. I'm going to divide the -4 on both sides. And because I'm dividing by a negative, I'm going to switch my inequality. And then -4 divided by -4 is 1. So when I think about graphing this one, I would put -3 and then 1. Something that's definitely in between is 0. Something that came before is -10, and something that came after 1 is 10. Now, on the -3, it is not equal to, so open circle. On the 1, not equal to, so open circle. Over here, x needs to be less than, so that's that way. And over here, x needs to be greater than, so that's that way. So that's that first scenario graph that we had on this one. And I will tell you guys, more often than not, that's the graph you're going to get for or. You don't often get this middle scenario or this last one. So usually it's the one where they're going in opposite directions. Okay, let's try another one. So if I draw on my sides right here, I'm going to get y alone. So I'd subtract the 7 away, and we'd have 5y is less than or equal to -10. Then I would divide my 5. And so y and -2 over here. And I won't switch my sign because the number on both sides that I divided is not negative. So I just bring my inequality down. Or we're going to solve over here. And so I'd get rid of addition, subtraction first. I'd add the 2. And so I'd have 3y is greater than or equal to 15. Then I would divide my 3 away on both sides. And so y, and then over here we got a 5. And again, the number that I divided on both sides is not negative, so I will not change that sign. I'm just going to bring it right down. And if I think about my number line here, just doing a quick one, we got -2 and 5. Now these are both equal to, so they'll both be filled in dots. And we're saying that y, doesn't matter, has to be less than -2, which is that away. Or y has to be greater than 5, which is that away. And so you can see we get that same going away from each other graph. Okay, good luck. Hopefully this one goes okay.